of radical equations. It's a secondary math 3 topic. We've already done some stuff like this in secondary 2. It's just in secondary 3 they're a little bit more advanced, but not too bad really. Okay, so same rules apply. You first isolate the radical completely, which means nothing is multiplied to the radical, most important. Nothing's added or subtracted to the radical. Isolate the radical on one side of the equation. Then second, you undo the radical. We're solving for a variable. You'll undo the radical using the correct inverse. So if it's a square root, don't we square both sides? If it's a square, don't we square root both sides? If it's a cube root, don't we cube both sides? You get the gist of it, right? Right? You get what I'm saying? Okay, and then third, then after that, after you undo the radical, you'll algebraically solve for the variable. Now third, you have to check for extraneous solutions. So in secondary 2, you don't have to worry about extraneous solutions. Extraneous solutions are solutions that come out, and yeah, you got it correct, but if you plug it back in, it doesn't come out with a true statement. So what happens, how those extraneous solutions happen is, we take and we change and manipulate these equations so much that you've done so much to it that it introduces an extraneous solution. So a solution that you will throw out due to manipulations that wasn't truly a solution. Does that make sense? So you do that by checking it. Do you get what I'm saying? So in secondary 2, when we're solving, we don't worry about you checking your answer. In secondary 3, you have to check your answers by plugging them back in, because you will get it wrong. I promise. If you don't, sometimes there'll be 2 extraneous solutions, sometimes there'll be 1, and then sometimes there's none. If you don't check, you'll get it wrong. On the end of level test, students checked, and they knew I have to throw out this answer, keep this one, and that's so on and so forth. So secondary 3, the problems are just a lot harder, and they have a lot more manipulation involved, so that's why we check for extraneous solutions. Okay, here we go. Problem number 2. So we're just solving. It's a square root equation, pretty easy, right? Isolate the radical, so what do we do first?
Square root?
No. Isolate the radical, what will we do first? We've got to add 5 first, right? So we have the square root of 4x plus 1, that's all under the roots, equal to 5. We've isolated the radical, nothing's multiplied to the radical or divided or anything like that. So how will we undo the square root? Square both sides of the equation. So on this side, root cancels out with power, leaving us with 4x plus 1 is equal to 5 squared 25. From there, we're solving for x, right? Pretty easy. Subtract 1. So we have 4x is equal to 24. Divide by 4. X is equal to 6. Now, we're going to say, okay, that might be our solution. In case it's extraneous, we better check. So you do that by, you have to check in secondary 3. There's just no other options. You plug it back into the original. So we're plugging in 6, right? Yeah. So when we have the square root of 4 times 6 plus 1 underneath minus 5, that better equal 0. So isn't this the square root of 24 plus 1? Minus 5 is equal to 0. So we're checking it at the square root of 25 minus 5 is equal to 0. Isn't that 5 minus 5? Equals 0. 0 is equal to 0. We've checked it. It did come out right. Therefore, we get to keep the solution. It was not extraneous.
So what happens if it's not?
If it's extraneous, then it's just not a real solution. You throw it out. It's not an answer. So let's say we threw this one out, then this one has no solutions. There was no other solutions, right? So we'd say no solution. It does happen. So, okay, next one, ready? Number 9. I'll tell you what, holy cow, my secondary 3 kids, they struggled with this problem, but you guys are really good at quadratics. In fact, I went to teach this and realized, holy crap, these people don't know how to solve a quadratic. I had to spend like 10 days reteaching them quadratics. You guys will breeze through this next year. The first rule when solving a radical is isolate the radical. So what are we going to do first? Add 5 to both sides of the equation. So we have the square root of x plus 7, both under the roots, equal to x plus 5, correct? Now what will we do to undo the square root? Square both sides, right? Guys? Square. Now don't I need to put all, isn't it squaring that entire side? Yes. Okay, so we have root canceling out with power. We have x plus 7 is equal to, can I square that, square that? We can? Since when, right? That's the forbidden rule that we learned at the beginning of the year. So we know that when solving a quadratic, we can't just square that. We rewrite this as x plus 5 times x plus 5. So we really have x plus 7 is equal to, we're going to double distribute, x squared plus 5x plus 5x plus 25, right? Now remember, our goal is solving for x. Right now we have x plus 7 is equal to x squared plus 10x's, right? Plus 25. Now this is where, like, I literally realized Secondary 2 did not know how to solve a quadratic, but we do. We get a set equal to 0 solve, right? So we subtract x. Let's think on an advanced level, guys, now that we're, on to the next year's stuff. Can we subtract 7 at the same time to make it 0? So I'm subtracting x, subtracting 7. Make sure your inverses come out right. That does add up to be 0 on this side. That's equal to x squared plus 9x's, right? And then plus
18.
Yep, 18. It's quadratic, it's set equal to 0. I'm going to solve by factoring. What multiplies to be 18 adds up to be 9. If it does solve by factoring, that is. So won't that be 6 times 3?
Yes.
Can we quick factor it? Yeah, a value is 1. So this factored to be x plus 3 times x plus 6. It's set equal to 0, so then we set each of those equal to 0 and solve. So we get x is equal to negative 3, right? And x is equal to negative 6, right? Everyone? Now we better check. I'm telling you, if you don't, you're going to get wrong on your teacher's tests and on the level test. We got to check those. Didn't that take a lot of manipulation? Yeah, it did. So we check them. So let's go over here and check. So I'm going to just check x is equal to negative 3 first. So we plug in negative 3. Wouldn't that be the square root of 4, guys? Negative 3 plus 7 is square root of 4, and minus 5 is equal to, and x was negative 3, right? We're not going to do the plus 5, right? We're just plugging it into the original. You get what I'm doing?
Yeah.
So that's negative 3. So that is 2 minus 5 is equal to negative 3. Isn't that true? Okay, so we're going to keep this one. We know for sure that's a solution. Let's check the other one. We're plugging it in. We're checking x is equal to negative 6. Won't that be 1?
Yes.
Square root of 1 minus 5 is equal to negative 6, right? Isn't that what we're checking? So we have 1 minus 5 is equal to negative 6. Negative 4? Isn't 1 minus 5 negative 4?
Yeah.
Is negative 4 equal to negative 6? No. Therefore, that was an extraneous solution. We will not keep it. We throw that answer out. We did our math right. We know that for a fact. So thus, we throw that answer out. It's extraneous. And all that manipulation that took place, it introduced an extraneous solution. Questions? So guys, what this means, think about it. This equation only intersects that one spot. Don't they intersect at negative 3, right? So you could check it on your calculator. You could graph it, solve by graphing, but I want us doing algebra today. Okay. Let's go for number 12. So we have the square root of x minus 1 minus the square root of 5x plus 5. Your first rule, the easiest way to do this is to isolate a radical. Get a radical all by itself. Isolate the radical. So we have 2 radicals, but let's isolate them, meaning 1 on one side, 1 on the other side. So to bring this over, we're going to add the square root of 5x plus 5 to both sides. So now over here on the left, I'm left with the square root of 7x minus 1. And on the right, I now have positive square root of 5x plus 5. Does everybody see how I've isolated the radical? Okay, once you isolate the radical, you undo the radical using the correct operation. So what are we going to do? Square, not square root it, right? Square both sides. Now, isn't this one nice? This one actually comes out really pretty. This doesn't always happen, but I mean, this one does. It comes out pretty. Doesn't that cancel out with that? So we have 7x minus 1 is equal to, doesn't that cancel out with that? So we have 5x plus 5. Now isn't it just linear, easy to solve? So remember, our goal is to solve for x, so we're going to get x. The x's together, so I'm going to subtract 5x. So I have 2 x's minus 1 is equal to 5. Our goal is to solve for x, so we'd add 1. So 2x is equal to 6. Divide by 2, x is 3, right? Let's check it, plugging it back in up here. We have the square root of 7 times 3 minus 1. That's 21 minus 1. Isn't that the square root of 20? Minus the square root of 5 times 3 is 15. 15 plus 5 is 20. So the square root of 20 minus the square root of 20, that's equal to 0. Is this a true statement? 0 is equal to 0. Isn't that 0? So we keep it. There's our answer. Last one. Last one. Then the rest of the time will be yours to practice. So this is a radical equation. A lot of students don't realize it. It's a radical equation in disguise. Especially they don't realize it if they don't have a strong background in rational exponents as radicals. Remember, we learned a picture of our flower and our power, right? Our roots are on bottom, our power is on top. So looking at this, isn't this 3 times x plus 1 to the 2/3? Isn't that the same thing, rational exponent, as the cube root of x plus 1 squared? Right? So I'm going to actually just rewrite it like that. This is the same thing as 3 times by, this is a cube root. Roots are on bottom. Now x plus 1 was in parentheses, and it was squared, right? Don't forget that. Does everybody see how I just rewrote it? And now it's just a radical equation just like before. So the first rule is to isolate the radical completely. So what will we do first to this? Good. Don't forget isolating it completely. Divide both sides by 3, leaving us with the cube root of x plus 1 all squared is equal to 4. Now what's my next step? Cube it, right? Cube both sides. We need to undo the cube root, so we cube both sides. So now cube root and cube are inverses. They cancel out, leaving us with x plus 1 all squared is equal to 64. Now there's 2 ways to solve this. I had a student first hour say, let's multiply that out and then solve using factoring. And I said, well, there's an easier way. That's not wrong. But there's an easier way. Isn't this just easy to square root it? Yeah. So let's do that. But here's the important thing. We're solving. We just square rooted both sides of the equation. Root cancels out with power. We have x plus 1 is equal to
8.
And something else.
Negative 8.
Plus and minus 8. Isn't the square root of 64 when solving both plus and minus 8, guys? Right? You can't forget that. That's only with even roots. Cube root of 64 is not plus and minus. Do you understand that?
Yeah.
Cube root of negative 64 is fine. That would be negative 2 or whatever it is. I can't even think right now. Yeah, negative 4 it would be. Do you get what I'm saying? Cube roots, odd roots only have one answer. Even roots, you cannot forget plus and minus. So we have the square root of 64, that's plus and minus 8. So we really know that x plus 1 is equal to 8. We know it's x plus 1 is equal to negative 8. Then solving for x in each case, we get x is equal to when we minus 1. So 7. Right?
Yeah.
Then we minus 1, so when that would be x is equal to negative 9. Now we better check those to make sure that they're not extraneous solutions. Or one of them might be. Or both might be fine. Now you can just check it by typing it into your calculator. Let's check for x is equal to 7. Type it in like this. Everybody practice. Hit a 3. Parenthesis. 7 plus 1. Close your parenthesis. Caret. Now this 2/3 has to be in parentheses. You get 12 is equal to 12. Your exponent has to be in parentheses. We did get 12 equals 12, right? Did you get 12?
Yeah.
So we know we got to keep 7. Let's do that same thing with negative 9. Parentheses, once again, have to be around that exponent on your calculator. So we're checking x is equal to negative 9, plugging in negative 9 for x. Do you get 12 is equal to 12? You tell me. If not, we'll throw that answer out. Yes. So neither of them happen to be extraneous. So think about it, guys. This function is intersecting this straight line at 12 2 times, right? Since there's 2 solutions. Isn't that what that means? I saw a poor unfortunate soul in secondary 3 on the final exam. They had this and this. And it said, drag a point to the solutions. Ding, ding. Isn't that what the solutions are, people? Want to know what he did? This and this. That's wrong, right? Solutions of a system of equations are where they intersect, isn't it? Everybody get that, right? Okay. Sweet. Okay, I'm not going to do this one because we talked about, I'm just good. I think you're good. So you're going to finish the worksheet. This is what our game's going to be on tomorrow. Check your answers with me. First hour, they finished with plenty of time left. And now you've learned how to solve all types of radical equations. So next year will be easy for you.